Hello again, I'm George Flew, and I want to welcome you to another in the series of videos demonstrating how you, utilizing plain vanilla AutoCAD and the simple but powerful 3D toolbox, can take advantage of the power of 3D substation design. To summarize the 3D toolbox, it contains over 600 AutoCAD drawing blocks including switches, connectors, structures, etc., as well as numerous apps written in Microsoft VBA and AutoCAD Autolist. Now, I have received several inquiries regarding how a person with basic 2D design background can make the transition to 3D design. So to begin our design, we have to first set out some basic substation layout parameters. And to assist in that, I have a substation design that I did back in 1987. This was an AutoCAD design of its day for a substation in Jackson, Tennessee, and this substation consists of two bays coming in with 46 kV. They're 15, 20, 25 MVA transformers. They've got a center bay here where you can back in a mobile, so that defines the minimum width between these two structures to be 25 feet, and kind of pretty well sets in the width of the bays for these others. Now, the mobile also sets a height restriction. If we go over here and look at this is a 46 kV elevation across that 46 bus. We see we've got that set at 22 feet plus or minus, and that allows us to get our mobile in and maneuver it somewhat to get it in position. And then it also sets the height on our 12 kV bus. So that being said, the next thing is choosing the bus size that we need to put in on both the 46 and the 12. We go over and look at our substation design data sheet. We'll see that for aluminum bus with a single span fixed, both ends fixed, and since both ends of these are switch, both ends will have a clamped connector on there. The minimum bus size to accommodate a 25-foot span is 2.5 inch. So this sets our parameter for the bus size at 2.5 inch. On the 12 kV side, the ampacity of that is 1500, which is over 30 MVA. And since these are 15 MVA transformers, then that ampacity is certainly adequate for what we're doing. And generally, rather than doing a lot of different bus sizes, we will keep the same bus size throughout these main buses through here. So given that, let's go into our design. So let's go back to our AutoCAD drawing. And this is something you can certainly take advantage of if you have an existing PDF file or a JPEG or some other file that you can scan in. And then you can bring that in using insert. We're going to insert the PDF file as an underlay, and we want to pick the first page, which is that plan view that we were looking at, and do an insert, do a zoom to extents here. So the first thing I want to do is check the distance, and I need to do two things. Let's first check PDF snap is set to 1 so that it's on, and then I want to also make sure I've got my units set correctly in the new drawing, not to decimal but to engineering units with insertion scale in inches, and say okay. Now I can check the distance between on this span, and it says that it is in fact 75 feet and some small fraction of an inch, which is close enough for our work, certainly. Now, the next thing I want to do is create some construction lines that will allow me to locate the various pieces of equipment and the structures, etc., and give me something to snap to, so that I'm not just eyeballing it. And so I'm going to take advantage of the OSNAP properties of the PDF, and also an app that I wrote many years ago called Rule Y. It's a small AutoList program, and it will actually draw a line, and the Y-axis, wherever I snap, it will draw a line from the top to the bottom so that I get a line fully across the height, in this case, of the drawing. Before I do that, though, I want to set up another layer. I'm going to just call this construction, because these are going to be my construction lines. And I'm going to set the color on this to magenta, just so we can distinguish, and set that to as my current layer. And now let's do our rule Y. And everywhere we want to have an intersection between two lines, then we need to put us a construction line. So we want to be able to locate these structures. Typically we want to hit all of these dimension lines. In addition to that, we need the center of this transformer in this breaker, this bay, which would be this line. We need the center of this line, which means we also need the center of this line. And let's see if there's anything else here. I probably missed one, if so we'll come back and add it in. Now we need to do lines in the X direction, and of course I have a rule X, and since we don't want it to go all the way across the screen, I'm going to zoom in a little bit, and I'm going to do our rule X again on all the dimension lines. Here we don't have one on the transformer location, so we'll pick the middle of the transformer itself. And then one for the middle of the low side base. We won't need one for these riser structures. They will be part of the assembly. So let's see if I've missed anything here. Hopefully we haven't. One other thing I want to do at this point is let's go up here to our 0 layer, and let's change, which is where we have the PDF inserted. Let's change that transparency to 70% to kind of gray it out so that we don't, it doesn't get confused with the other things we're doing. And so at this point we're ready to start actually inserting structures and equipment, and this would be certainly equivalent to what you would do at 2D, assuming that you have 2D blocks created for your equipment and your different structures, etc. And if these are all individual blocks, then you would normally begin inserting blocks at this point, and we're going to do the same thing. So the first thing we're going to do here is open up our substation unit and apps, an assembly app, and we will begin with our 46 kV dead end structures, which just happens to be under structures. The first assembly that shows up just happens to be our breaker overhead 46 kV. So to insert that, we've got intersection selected here. We just click insert, and we snap to our intersection on our construction lines, and here we need to rotate that 90 degrees, and we'll notice here if we zoom in that it's rotated such that the 1, 3, and 5 bushings are both on the line side, which is what we typically want on our dead end structure. Let's go ahead and insert another one over here, and once again we need to rotate that to the line side, which I'll hold down the Alt key and hit the rotating Z, and it'll rotate a full 180 degrees. So there we have that. Now let's go back over and refer back to our substation layout, and let's scroll down here and look at some of these structure heights again. As we said before, this height of this 46 bus is set at about 22 feet, which means the height of that structure is 1.5 feet or so below the bus itself. So if we go back then to our drawing, and we look here at this structure here, we're looking at a pie structure, and it's a 04, which would be 46. So to get 22 feet, we're going to pick the 20-foot pie structure, And again, intersection is selected, and we will place that one. Now, these are both switches, so here instead of a pie structure, we're going to use a switch assembly, and it's going to be a 3-pole vertical brake 04. It does call for a vertical brake switch on that, not a V switch, and so we need one that's 22 to match a 22-foot height. I'm not real sure if this 18 is going to actually reach the height we need or not. If not, then we need to go in and on the fly create one that does. But let's go ahead and insert that, and we will insert that here at that intersection. And you notice that if we zoom in, you notice that here the blades, we want the blades to open toward the bus here, this bus span. So that's correct. And then we'll insert another over here, and in order for them to open the same direction, we will spin that 180 degrees so that they open correctly. And so now we have the 46 bus line set up. So at this point we need the structures, these 3 structures. And if we go back over here to our Acrobat view, we will see that those structures are all they're 17'6" to the bus. So this structure needs to be somewhere around 16 or so feet tall. So we'll go back to our AutoCAD drawing, and here let's start out with our pi 04, and here, so our first one that comes up is a 16-foot. So let's insert it, and we'll need to rotate it in the Z-axis. Now I can go ahead and insert this 3 times, but I'm going to go ahead and take advantage of the ability to copy multiple blocks at one time, multiple units. So I'm going to go up here next to insulators, and that insulator for that is a TR267, and we will insert that at a node. Now at this point we can't really see our nodes. The nodes exist there. I'm going to use a PD toggle. It's another little app, and initially it will toggle them off, and then I'll toggle them back on. But when they come back on, it sets the size on them so you can see then the nodes. So that just made them visible for us. So I'm going to insert that insulator, and now I need to put a connector on top of that insulator. Now, unfortunately, there's 2 node points. There's a node point on the structure and a node point on top of that insulator. So I am going to take and shift it slightly in the 3D direction so I can see that. And I'm going to go up here to my connectors, and I'm going to put a base connector, and I'm going to put a slip connector. And so here is my excuse me, not base, but bus support slip connector, aluminum 2.5 inch. And I want to insert it at this node, and you can see I need to spin that 1 time in the Z direction. Let's just get back to our original view here. Zoom previous. There we are back on top. Now we want to copy that to all these structures. So, and the way I want to do that is first I want to select the connector and then select the insulator, because when I do the copy command, it uses the base point of the last unit that was selected. So I want it to be the insulator because I want to copy it to all these node points. So now that we've copied it to these node points here, we want to copy the structure along with the insulator. And then we're going to select our insulators and select our structure, do a copy. Now we've got a nice intersection, which I had not chosen, so we can't find. So we can't. But we'll just type it in, And there we have those three structures complete with their insulators. Moving on down here, we've got the transformer, so we'll go down to major equipment. If I scroll down, here's our 250 kV BIL 25 MVA transformer set for intersect, so we'll do an insert. And again, we'll need to rotate that. We can simply copy that to here. Now once again down here we've got two structures and two switches. Let's go up here first and do our switches, and keep in mind that that bus height was 22 feet. So here we're going to do a switch. This one will be a 4-pole vertical, excuse me, these were V switches, 01, and so we want, for a 22-foot bus height, the height shown here is based on the structure height, not the height at the switches. So we're going to use this 21-foot structure, and we will then come in here and put this in here. And being a V switch, we don't have to worry about the orientation of that switch, so we'll put one in both of those. However, we will, let's just take this last one and spin it so that we get our grid, so it's not in the mobile bay area. And then over here, what we'll want is a high structure, 01, and the 21-foot. We're going to insert that in here, and then on that we're going to insert our insulator at 12 kV. These are 225s, TR225s. Again, we'll insert here on this node, and then we'll go in here and tilt this slightly and zoom in here, and we'll then place our connector, which again will be a bus support slip, and our 2.5 inch. We'll insert it here, and we don't need to rotate that at all. So now we want to copy it to these. This has 4 buses on it, one for the neutral. So I'm going to select the connector first and the insulator second, so that I can copy it by the insert of the insulator. And we'll zoom back here to where we're looking down on top of our structure, and we want to copy that. So I'm going to first select all the insulators and connectors, and then I'll select the structure as the last one, so I can copy it based on that insert point, and I'll copy it over to here. And so there we have our low side structures in. The next we want to put in will be our regulator. So we'll go over here to it'll be a structure because we wanted it's an assembly with a voltage regulator in it. So here is our assembly, includes the regulator, and we will insert that here at this intersection point. And then we want to rotate this 90 degrees, and just zoom in to see you can see our switches are on the line side, and then we'll copy that over here to our other location. And so we have our regulators in. Now we need to put in our low side bays. So what we'll do is we'll go back to our construction layer, and we need to turn back on our PDF snap. Turn it back on, and then we can do our rule Y, and we'll select this line here, and we get a Y line there. So we'll go back over here to our PDF snap, turn it back off. Now we want to select our breaker assembly, so we'll select breaker, and this is going to be an underground breaker, and we will be using this. I believe that we want to use a 3301 here, which is specific to the bus type on it. So we want to insert it here at this intersection, and of course we have to rotate that in the Z-axis one time. Now the next one we want to put in, we can't continue to put in this same one because it will duplicate these structural members in this column over here. So we'll go to the 3401, which has eliminated that, and we will do an insert. Now I don't really have anywhere to insert it, so I'm going to insert it back here on this same intersection. We will then rotate it one time. And so we want to move this in the x-axis, and the x-axis positive is to the right, so we want to move it to the left. So we're going to move it in the x-axis. We'll move it minus 15 feet, and that then puts it over here in this other bay where it belongs. Now, what I want to do here, instead of inserting and moving, inserting and moving, I'm going to use the array command, and I personally like the classic version. So what we want to do here is build an array that's got one row, and we need 1, 2, 3, 4, 5, 6 columns. 6 columns, and then we want the column offset to be minus 15 feet. And then we want to select our breaker, and then we'll do a preview. That looks good, so we'll just hit return, and that will accept that. Now, at this point, we've completed all the structure installs. I will point out that this bay is a tie bay between these two main buses, and it needs some modifications. We're not going to go into that modification at this point. It's a little bit lengthy, and it's simple enough. It's a matter of exploding it and deleting the underground dip, changing some of the switching around. So I'll leave that up to you to look into. But what we've done here basically is we've accomplished our original intent, which was to locate all of these structures. Let's just go in here and we'll turn off our construction line and our layer 0 so we can better see what we've done, what we've accomplished. At this point, I would refer you back to video 2, which shows how you go about installing bus and jumpers. So one last exercise I want to take here is we will rotate this to a isometric view, and we'll go up here and let's close this, and we'll change this from our traditional wireframe, which is what we're generally working in 2D, and we'll go to a realistic, and you can see here that now we have our more realistic version of our substation view. And so with that, I think we will call this complete. And as always, feel free to contact me with any questions or comments. Just go to the 3DUtility.com page, and up in the right hand corner is a contact page in the menu, and from there you can send me any questions or comments. And with that, again, thank you. Until next time.